Hi, we are discussing the fourth numerical from the exercise for the chapter Gravitation. So let's start. The question is two satellites named A and B are revolving around a planet, a common planet. The periods of revolutions are 1 hour and 8 hours respectively. The radius of orbit of satellite B is 4 into 10 raised to 4 kilometers. Now find radius of orbit of satellite A. So we have two satellites named A and B, which are revolving around the same planet. And the time period for satellite A is given to us. We represent it using the symbol T of A, capital T of A, and this time period is 1 hour. And the time period required by the satellite B to complete one revolution is given to us as 8 hours. अपार्ट फ्रॉम दीज टू इन्फॉर्मेशन हमें एक और क्वांटिटी के बारे में इंफॉर्मेशन अवेलेबल है दैट इज द रेडियस ऑफ ऑर्बिट ऑफ सैटेलाइट बी so we represent the radius of orbit of satellite B as the term R, capital RB, and this radius is said to be 4 into 10 raised to 4 kilometers in length. And using these three given quantities, हमें ढूंढना है the radius of orbit of satellite A, and we represent that quantity using the term R of A. So over here, we are representing radius of orbit of satellite A. That's what we are required to find. So let's try to understand what sort of formulas we can use. So time period of a satellite is defined as 2 into pi into under root of r cube, where r cube is the distance between the satellite and the center of the planet, or the radius of the orbit, the whole thing divided by g, that is the universal gravitational constant, into the mass of the planet. So this is the formula for calculating the time period of a satellite revolving around a planet at a distance small r. And we can use this formula to calculate our radius of satellite A. So from formula, first, we can establish a relationship between the time period and the radius of the orbit. So if I were to square on both the sides, then I can say t square is equal to 4 pi square into square root of r cube divided by gm ka square, that is the term r cube divided by g into m. So from this, I can say that the square of my time period must be proportional to the cube of the radius of the orbit, because for a given planet, the term 4 pi square divided by g into the mass of the planet is always constant. So this term is constant for a given planet. And since both the satellites are revolving around the same planet, the term 4 pi square upon gm would be constant. So I can say that t square is proportional to r cube. Let this be our expression number 1. So from this, I can say that the time period of satellite A ka square divided by the time period of satellite B ka square is equal to the radius of satellite A ka cube divided by the radius of satellite B ka cube. This is from the ratios of the proportional quantities. And we know the quantities of TA. So TA is given to us as 1 hour, and time period of satellite B is given to us as 8 hours. So 8 square is equal to the radius of orbit for satellite A is unknown to us, so we keep it as it is. And radius of orbit of satellite B is given to us as 4 into 10 raised to 4 iska the whole cube. Now let's bring all the unknown terms on one side. So RA cube is equal to, and all the known terms on the other side. So RA cube is equal to 4 into 10 raised to 4 the whole cube divided by 8 square. And if we solve this further, 4 into 10 raised to 4 ka cube is 64 into 10 raised to 12, and 8 ka square is 64. So we can sort of cancel 64 in the numerator and 64 in the denominator, giving us the value of RA the whole cube, that is the radius cube, is equal to 1 into 10 raised to 12. Now let's take cube root on both the sides. So taking cube root on both sides, इससे हमें मिल जाएगा हमारा RA, because RA cube का cube root is RA is 1 into 10 raised to 4, as the cube root of 10 raised to 12 is 10 raised to 4, and this is in kilometers. So the radius of the orbit for satellite A is 1 into 10 raised to 4 kilometers, that is 10,000 kilometers. And that's it. If you want the PDF of the solution, make sure you check the description. Thank you.